Hello everyone, my name is Lopez, and this is my final project for CIS 25, SHAKEY, your Earthquake Preparedness Assistant. This project combines real-world emergency readiness with solid C++ engineering. My goal is to build a tool that helps households prepare for earthquakes in a simple, structured, and personalized way. SHAKEY is a digital earthquake readiness assistant designed to walk users through every step of preparedness. The program collects household data, generates personalized recommendations, tracks inventory, and stores information for long-term use. The core idea is to take complex safety guidelines and translate them into an easy, guided experience. I wanted this project to be meaningful beyond the assignment itself. Living in California, we all know earthquakes are not hypothetical. They're guaranteed, even just this last week. But many households aren't prepared. Families with medical needs, pets, or limited resources are especially vulnerable. SHAKEY provides structure where people often feel overwhelmed. From a technical perspective, the project allowed me to demonstrate modular design, file persistence, user input handling, and multi-class architecture, all essential to C++ development. SHAKEY is built around 6 key features: profile creation, the household survey, a personalized recommendation engine, an inventory checklist, data persistence, and CSV import-export. Each feature connects to its own module, making the program both organized and scalable. The survey module is the foundation of the program. It gathers detailed information such as demographics, medical needs, pets, utilities, and household preferences. I use getLine as safety to capture multi-word responses and prevent input issues. All these responses are stored in a HouseholdProfile object, which becomes the driving data source for recommendations and inventory checks. I'll switch to the code for a moment to show how the survey is structured. Here you can see the section that handles input using getLine. Each response populates the HouseholdProfile object, one category at a time. This modular input approach makes it easy to maintain the survey or expand it later. For example, adding special needs categories or more pet-specific prompts. Now that you've seen how the survey gathers structured data, let's look at how SHAKEY transformed that information into actionable recommendations. The recommendations engine is where SHAKEY becomes personalized. It uses FEMA and CDC guidelines as a foundation, but scales the supply list based on the household's specific needs. Pets, medical conditions, household size, and utility dependencies all influence what's recommended. The output is a vector of recommendation item objects that define the emergency kit for that household. The inventory module helps the user identify what they already have and what they still need. It compares actual supplies against the recommended list, flags shortages, tracks expiration risk, and produces a summary report. This is where planning becomes action. The user can start building their kits step by step. I'll show a quick example of the file persistence system. This function writes the profile data to a .dat file. Using formatted key equal value pairs makes it reliable for saving and reloading the user's information. Below that, you can see the CSV export loop, which writes each item into a row. This allows the inventory or recommendations list to be opened in Excel, Google Sheets, or shared with emergency coordinators. Now let's look at why CSV support is such an important real-world feature. CSV functionality gives users a professional way to track their supplies over time. They can export a full inventory snapshot, update it externally, and then import changes back into SHAKEY. This makes the program useful beyond the terminal. It becomes part of an ongoing preparedness strategy. SHAKEY uses a clean list of classes to keep the code organized. Each class, survey, recommendations, inventory, and the item models handle a specific responsibility. This mirrors real engineering practices and makes the program easier to test, debug, and expand. Some of the main challenges included input validation, managing multiple modules, and creating a simple but reliable file system. By separating logic into clear classes and designing consistent data models, these challenges became manageable. The modular approach also made it easier to add new features without breaking existing ones. Did I mention the logic? While the current version of SHAKEY runs entirely through a command line interface, we also began exploring what a future GUI could look like. The goal behind a graphical interface would be to make Earthquake Readiness even more accessible, especially for users who may not be comfortable with a text-based program. We haven't built the GUI yet, but the concept focuses on simplifying navigation, organizing the survey into clean sections, and visually presenting recommendations and supply lists. This is an enhancement plan for future development once the core logic and features are fully tested. The program is intentionally designed for future growth. Some planned features include HTML and JSON export, expiration reminders, a more sophisticated notification system, and eventually a mobile app version. Because their underlying architecture is modular, these features can be added without rewiring the core logic. In conclusion, SHAKEY is both a technically robust C++ program and a meaningful tool for community safety. It demonstrates modular design, data modeling, file persistence, and applied problem solving. Preparedness saves lives, and SHAKEY helps households take the step in a clear and personalized way. Thank you for watching.